If you're going for a walk, you'll often look at an Ordnance Survey map and think, right, this is how I'm going to plan it. This is quite a big hill, and quite a few people have climbed it. Our CEO has climbed it 3 times. I think you'd know it as Everest. But that's what it looks like on a contour map. And that's what it looked like when Alison went to the top. And in a way, I liken this analogy to MRI and CT. And what we at Holocare do is take these flat slices of CT or MRI and convert them back to their original 3D form and as an interactive hologram. And we're just superimposing a liver hologram. These 4 people are wearing the headsets. We happen to use the Microsoft HoloLens at the moment. We could use any. And they're all visualizing the hologram that was derived from DICOM CT slices. They can interact, so those 3 can see the 4th person pointing in to the tumor, looking at the excision sites, etc., etc. So I find that when I'm talking to the likes of Professor David Jane or Peter Lodge here, and they're pointing at that, I've no idea what they're pointing at. And they say there's a huge tumor, I take their word for it. But if I'm looking at that, I can see that yellow bulb and say that's where the tumor is. So what we do is we generate patient-specific holograms from their CT or DICOM, and then it can be visualized. You can see here we've set up an interactive MDT tumor board meeting where the various surgeons are now looking at it. Is that patient operable? Is it resectable or not? Or is it going to have to be put on palliative chemo? The technology was derived from work we did at Oslo University Hospital, where the surgeons there said, we want to see an interactive 3D view of what we're going to operate rather than just 2D slices. So it came out of Oslo, and the clinicians we've been talking to across Europe, these are all speculative. The MDT is the only proof point where we can show we're reducing the time of an MDT, which is the most expensive part of a care pathway, because you may have 5 consultants in one meeting looking at one patient. But talking to a number of cancer centers across Europe, they're believing that it's going to lead to, hopefully, better efficient surgery, less complications, shorter time in ICU, faster recovery, and the patient gets out. And the hospital benefits, we hope, from better utilization of the care pathway. In Leeds, we're working with Karen Van Dorn. She's taking 100 cases from the Gerlis collection. These are congenital heart cases. And rather than being in the biobank in a test tube, we're creating interactive holograms for teaching and display. We're working with Professor Peter Lodge. He's evaluating our CE-marked liver surgical product. And finally, we were successful, fingers crossed. Professor David Jane, still not sure how we got it, but we got 8.9 million out of Brussels. And Leeds, with Professor David Jane, Dr. Stocken, and Peter Lodge are helping us drive this. And the Holosurge project we're going to be creating and evaluating here at Leeds. We're going to fuse MRI and CT for preoperative, then overlay ultrasound into the intraoperative stage. Thank you.